So let's talk a little bit, and what I'm going to now do is kind of walk through some of the AI workflow and some of the complexities that our government clients have told us and some of the challenges that they're facing as they go through this workflow. So I've laid it out here, and we typically, group all of these different stages into two major stages: training the model and inferencing. So I'll highlight just a few of these challenges as I go. So let's take a look at these two. First, data acquisition. So we know machine learning just takes large volumes of data, but we also know government probably has more data than any other industry in any other sector. However, even with that, AI algorithms typically need 8 to 10 times the volume that are used for traditional analytics. And we know that effectiveness in training the model depends on more than just volume. It depends on high quality and dynamic data inputs. So, we work with our agencies and we caution them to make sure their data is diverse, as ethical AI must include multiple viewpoints. And that'll just be so important for a well-rounded, fact-based approach. And then we also know AI decisions are only as good as the data that's provided and analyzed. And this kind of leads us to the next point then, following basic data management practices as agencies prepare their data. So a lot of questions that we ask our agency clients include, do you know the lineage of your data? Is it clean? Is it granular enough to be useful? Do you have processes in place to document sources? Are you labeling and organizing your files? And how are you addressing issues with respect to integration of data from so many different data sources? And this is not a glamorous step, but proper data management is so critical to properly training the machine. So if we look at this next step, these include training, testing, and tuning, and these are not trivial tasks. So here we see examples of machine learning algorithms that are used in training your system. And so I'll walk through them quickly. Supervised learning, that's basically teaching the machine to learn from a data set. And this can include such algorithms as decision trees, linear analysis, or supervised neural net models. And we're seeing agencies such as Border Control and Protection use this for facial recognition. And that's basically to prevent bad actors from entering the country. But we're also seeing examples like U.S. Patent and Trademark. It speeds image recognition and can actually start to grant patents a lot faster. So unsupervised learning. This technique models the underlying structure of the data to actually discover patterns that might be hidden in the data and are typically not visible to humans. And so this modeling can include such algorithms as density estimation, clustering. And we know that clustering is currently used, to visually understand the increased activity, say, of bad actors, right? But we're now expecting agencies to increasingly use clustering to monitor and predict the hotspot of the COVID-19 virus. So finally, reinforcement learning. Now, this trains the machine learning models to make a sequence of decisions for such use cases as drones and robot navigation and also self-driving cars. So if you can see, just by this step in the process, agencies have to select the best fit approach to their machine learning. And then once they do that, they're literally choosing from dozens of algorithms to train the model. All right, so the next area that we think is just so critical as agencies are moving through their workflow is ensure that the testing for bias is done. And we suggest test, and retest, right? So this testing on personas that agencies are typically created before they start to train the model is so critical at this stage. And we've seen that bias can be mitigated through human-centered design practices that are very inclusive of various populations that the agencies serve. And then through testing, they can ensure that their AI decisions do not harm these personas. And let's take another look then as we move into the workflow into training. And one of the things that we advise agencies on this is to pay particular attention to the AI systems that continue to learn after you've deployed them. And this is true, especially if learning takes place under unsupervised conditions. And we were observing that many agencies find it difficult to predict the system's behavior And so these systems really need to undergo routine performance assessment. And I compare this to hiring a new employee. You wouldn't give them a laptop and just tell them to go, right? You need to make sure and you're monitoring and their performance is actually ensuring mission effectiveness. So the last area that I'm going to cover on complexity is addressing the level of false positives. And agencies know that they may have a lot of repercussions from making decisions with a high percentage of false positives. This may actually impact constituents inappropriately, and it may do such things as denying benefits. And of course, then agencies are going to hear about this through their elected officials. But it's just as important to reduce the percentage of false negatives, or you might be letting bad actors off the hook. So in addition to addressing the complexities of the AI workload, there are many, many AI stakeholders that need to be engaged. And as you can see by this, the chief data officer or the data scientist, they're the rock star, and they're right there in the middle of the organization. But we urge our clients, don't forget about some of the other key players. And if you think about it, legal counsel, well, they may need to determine what data sets can and can't be combined. When we think about CHICOs, they may need to accelerate bots and to accreditate bots, And you know, they're also responsible to ensure that the agency's plan for the future skills required. And this is so critical as machines start to take a bigger role in analytics, in decisioning, and in actions.